Here's problem 1719. A person standing in the street is unaware of a bird dropping that has fallen from a point directly above him with increasing velocity. If the dropping were producing sound of fixed frequency, as it approaches the person would hear the sound what? Let's say we had a person here, and we have a dropping, and it's falling, but it's actually increasing, so there is an acceleration as it's falling. So that velocity is increasing. That is the velocity of the source. In this case, the velocity of the observer is 0. So the observed frequency is the actual frequency put out, velocity of sound plus or minus velocity of the observer over the velocity of sound minus or plus the velocity of the source. Well, in this case, the velocity of the observer is 0, and the velocity of the source is approaching the observer, so we're going to use the top minus sign for toward. So our observed frequency is going to equal the actual frequency, velocity of sound over the velocity of sound minus the velocity of the source. Now this would be constant if the velocity of the source were constant, but since the velocity of the source is increasing, so the velocity of the source is going up, then, and that's in the denominator being subtracted from the velocity of sound, we'll find that that denominator will get, so the net effect of that is increasing the value of that fraction, v over v minus vs, as vs goes up, because the denominator is going to get smaller and smaller in value. So as vs goes up, so will the observed frequency, and hence we will observe an increase in frequency as it drops and accelerates.